Welcome back. In this third and final density lesson, we'll continue our focus on calculations, but this time we'll be given the density and we'll need to find mass or volume. Now you're all familiar with aluminum foil, but aluminum, because it's a relatively low density metal, is also used in airplane fuselages. So let's say you work for the airplane manufacturer and you need to calculate how much mass of aluminum you need. There are two ways to solve these problems. The first way is to use the density formula and solve for mass. That's perfectly correct. I am not going to teach it that way, however. Instead, we'll use the conversion factor strategy because that is consistent with the overwhelming majority of problems you'll encounter in introductory chemistry. It will help you out far more in the long run. And also,
because it's the right thing to do.
So the first thing you need to know is that a given density can be converted into two possible conversion factors. 5.3 grams per milliliter, for example, can become 5.3 grams over 1 milliliter, or 1 milliliter over 5.3 grams. Same type of pattern in this next row. Okay, stop the video for just a few seconds and fill in the possible conversion factors for the density of aluminum, 2.7 grams per centimeters cubed. Okay, hopefully you have something like this. First problem. If you're given the density of aluminum and you know the required volume, what is the corresponding mass? Using the conversion factor method, we start by writing the desired unit of grams. Then we write our given quantity and start to construct our conversion factor, putting centimeters cubed on the bottom so it cancels. Now we put grams on top because we want to end up with grams. But it's only okay to do that if you know a relationship between grams and centimeters cubed for aluminum. Well, we do. We know there are 2.7 grams in every centimeters cubed. So we put 2.7 in the numerator to make it that many grams per centimeters cubed, and then we do the math and get our answer. So here's an example of using density as a conversion factor. In the next problem, we need to solve for volume, in particular centimeters cubed. Like before, first clarify we need to head to centimeters cubed. Then start your calculation with the given mass, followed by starting with your conversion factor. This time we put grams on the bottom because that's what we want to cancel. Then centimeters cubed goes on the top. And since there are 2.32 grams for every 1 centimeters cubed, we need to put 2.32 on the bottom because grams is on the bottom. If you put 2.32 on the top, it would be like saying there are 2.32 centimeters cubed per gram, and that's not accurate. Then do 1.2 times 10 to the third divided by 2.32 to get your answer. Again, rounded to the correct number of significant figures. Two more problems. In this one, we need milliliters, and we're given the density and the mass in kilograms. I'm going to get you started, and then I'll ask you to finish it. Write down our endpoint, which is milliliters. Then write the mass given, and since it's in kilograms, that means for our conversion factor, we need kilograms on the bottom to cancel it. Now I want you to finish it. Two hints. One, finish this conversion factor here, and then two, make a second conversion factor and only then do your math to find the answer. Stop the video now. Okay, we put grams in the numerator, not milliliters, because we don't know how many kilograms are in a milliliter. But we are expected to remember there are 10 to the third grams per kilogram. Then for the next conversion factor, we cancel grams, and now we go to milliliters because we do know how many grams are in a milliliter. Because it says here there are 1.43 grams in every milliliter, we know to put the 1.43 by the grams. We then do the math to get our answer. Again, rounded for sig figs. Okay, last one. I'll again get you started. This time we need to solve for a mass again, specifically kilograms. Then we start our calculation part with 946 milliliters. Now, if you're wondering, how do you know to start with this value instead of this one? In general, if you're solving for something that's not a fraction, kilograms is not a fraction, then don't start with a fraction. And this density is really a fraction. Okay, finish this on your own. My hint is you'll need two conversion factors. Stop the video now. All right, here's the worked out solution. Make sure to ask in class if you have any questions. To review, the new idea in this lesson was to use density as a conversion factor when it's given, like we did here and here. When we need to find the density, like in the density part 2 lesson, we use the formula density equals mass over volume. Well, thanks for listening, and see you next time.